Very quickly, here's the beginning, general idea of what you're going to do for homework. Packet page 16, we're going to do that together right now after I show you a few things. Packet page 17 to 18, you're going to have all the mechanics and all the math done, everything ready to get together in groups and give me a final product for your group. On Monday, you'll have 15 minutes to do so. Page 466, number 28, do that one in your spiral, and page 469, numbers 1 through 4 and 10, do those in your spiral. So that's the homework in a nutshell. Real quickly, for those of you who weren't in class, here are the basic idea of the notes that I gave you on the last video. You'll notice at the bottom we added a little bit in. You'll see that again on the next one. So the success failure, and then we said since the conditions check, we can use a normal model to run a 1 proportion z test, and that's that new piece in this section, chapter 20. Once we check everything, you'll notice all the mechanics. We have the p-hat value of 0.94. That's kind of what we're looking at. What's going on with that? The normal model is the 0.9 and the 0.015. That has to do with the value that was given to us as like a reported value. The p-value that we have there, that p-value is just the right tail of that picture. It's how the 0.94 that we found kind of goes along with the original 0.9. We use the normal CDF to find that 0.004. Since we have a low p-value of 0.004, we will reject our null hypothesis. There is a strong evidence that the city has more than 90% of the homes with smoke detectors. That's kind of the general idea. There's more examples in the book and stuff. Text me or email me if you have any questions, and I'm going to go on to the next problem. All right, here we go. I want to try to make this quick so I can upload this sucker fast. All right, so we're looking at 20% of the M&Ms is supposed to be orange. That's what's reported to us. We did a little study, pulled out a bag, 21 out of 122 were orange. Does this contradict? It's going to be two-tailed. Two-tailed because we want to know if it contradicts it. Is it more or less? I don't care if it's more or less. I don't care if what I got was off. I just want to know, is it different? No hypothesis. Is the proportion 20%? Alternative, is it something else? In symbol form, null hypothesis, is my value 20%? Alternative hypothesis, is my value something other than 20%? Last problem we did was a greater than problem. Conditions, same. Okay, it's reasonable to believe that it's independent. The bag seems to be picked random, large enough, 10% condition. Success, failure, good, rock on. Since the conditions are satisfied, I will use a normal model to perform a 1 proportion z test, two-tailed. Two-tailed, 1 because it told me, but 2 because I wanted to know, is it different than what they reported? I'm not asking higher or lower, just is it different? When you go through that, you're going to start with your values, your information. This is the basic information for my sample. Here's what the picture looks like for the problem. Now remember, this information came from knowing that this is our value, our p-value that was reported to us. Now the standard deviation, that's another story. You want to make sure you figure that out. So my standard deviation is going to come from the 0.2 times the 0.8 over 122. Now if you calculate that, that standard deviation is going to be 0.164. Now we want to know where our 0.172 lies. Now it ends up being below, but we also want to remember that because we're doing two-tailed, we want to look at both sides. So we just figure out the distance between our original given value, the 0.2%, 20%, and then this value, and then we just go up and we figure that out. Now what we're going to do is we're going to calculate one of these two pieces. We're just going to double it. So it doesn't matter which one. Let's say we calculate this piece. We have a normal CDF, lower bound, negative 999, upper bound, 0.172, mean, proportion value is 0.2, and then our standard deviation, 0.164. When you calculate that, that comes out to be 0.44. I'm sorry, 0.22. What we're going to do with that then is we're going to multiply it by 2, so we have both ends, both pieces. And that means that our p-value equals 0.44. And then we need to know what to do with that. Our conclusion is going to be that we are going to, since our p-value of 0.44 is high, we fail to reject our null hypothesis. There is no evidence. So from our sample, we don't see any evidence to suggest that the proportion of orange M&Ms differs from the advertised or reported 20%. Hopefully that helps and makes sense. Rewind, go through it again. There's really nothing new here, it's just putting it all together. So now you're all set. 17 to 18 is going to be some similar problems, setting up your null hypothesis. So make sure you get your null hypothesis set up. Get a general idea of what those conditions are going to be, but go through that meat of it. Get the normal curve, get the p-value, come up with your standard deviation, get all that filled in so that you can do that quickly in class, 15 minutes at the beginning with your group, page 446, number 28, and page 469, numbers 1 through 4 and 10. Have a great weekend. Have fun at Join the Winners.